will affect human beings. When a large quantity of ethanol are consumed, it tends to slow metabolic processes and to depress the central nervous system. This results in lack of coordination, mental confusion, drowsiness, lowering of the normal inhibitions, and finally, stupor. The individual may feel relaxed but does not realize that his sense of judgment, sense of timing, and muscular coordination have been seriously impaired. Unlike ethanol, intake of methanol in very small quantities can cause death. Methanol is oxidized to methanol in the liver. Methanol reacts rapidly with the components of cells. It causes the protoplasm to coagulate coagulated in much the same way an egg is coagulated by cooking. Methanol also affects the optic nerve, causing blindness. Ethanol is an important industrial solvent. To prevent the misuse of ethanol produced for industrial use, it is made unfit for drinking by adding poisonous substances like methanol to it. Dyes are also added to color the alcohol blue is that it can identified easily. This is called denatured alcohol. Alcohol as fuel. Sugarcane plants are one of the most efficient converters of sunlight into chemical energy. Sugarcane juice just can be used to prepare molasses, which is fermented to give alcohol, ethanol. Some countries now use alcohol as an additive additive in petrol since it is cleaner fuel which gives rise to only carbon dioxide and water on burning insufficient air oxygen. Properties of ethonic acid. Ethonic acid is commonly called acetic acid and belongs to a group of acids called carboxylic acids. 5 to 8% solution of acetic acid in water is called vinegar and is used widely as preservatives in pickles. The melting point of pure ethonic acid is 290 K, and hence it often freezes during winter in cold climates. This gave rise to its name glycyl acetic acid. The group of organic compounds called carboxylic acids are obviously characterized by a special acidity. However, unlike mineral acids like HCl, which are commonly ionized, carboxylic acids are weak acids. Reactions of ethonic acids. Esters Esterification reaction. Esters are most commonly formed by reaction of an acid and an alcohol. Ethonic acid reacts with absolute ethanol in the presence of an acid catalyst to give an ester. Esters are sweet smelling substances. These are used in making perfumes and as flavoring agents. Esters react in presence of an acid or base black to give back the alcohol and carboxylic acid. This reaction is known as saponification because it is used in preparation of soap. Reaction with base. Like mineral acids, ethonic acids react with a base such as sodium hydroxide to give a salt. Sodium ethanol, or commonly called sodium acetate, and water. How does ethonic acid react with carbonates and hydrocarbonates? Let us perform an activity to find out. Set up the you can read it, please. As reaction with carbonates and hydrocarbonates. Ethonic acid reacts with carbonates and hydrogen carbonates to give rise to salt, carbon dioxide, and water. The salt produced is commonly called sodium acetate. This activity demonstrates the effect of soap in cleaning. Most dirt is oily in nature, and as you know, oil does not dissolve in water. The molecules of soap are sodium or potassium salts of long chain carboxylic acids. The ionic ends of soap dissolves in water while the carbon chain dissolves in oil. The soap molecules thus form structure called micelles in figure 4.2 or 12, where one end of the molecules is towards the oil droplet while the other ionic end faces outside. This forms an emulsion in water. The soap micelle thus helps in dissolving the dirt in water, and we can wash our clothes clean. Can you draw the structure of micelle that would be formed if you dissolved soap in hydrocarbon? Micelles. Soaps are molecules in which two ends have differing properties. One hydrophilic, this is it dissolves in water, while the other end is hydrophobic. This is it dissolves in hydrocarbons. When soap is at the surface of water, and hydrophobic tail of soap will not be soluble in water, and soap will elegant along the surface of water with the ionic end in water and the hydrocarbon tail protruding out of water inside water. These molecules have a unique orientation that keeps the hydrocarbon position out of water. This is achieved by forming clusters of molecules in which the the hydrophobic tails are in interior of the cluster and the ionic ends of are on the surface of cluster. This formation is called mycelium soap in the form of collected in center of the micelle. The micelle stays in solution as a colloid and will not come together to participate because of ion-ion repulsion. Thus, the dirt substance in micelles is also easily rinsed away. The soap micelles are large enough to scatter light, hence the soap solution appears cloudy.